Hello everyone, welcome to Electron Tech channel. Now we are going to see a problem in decimation in frequency, and it is an 8-point problem. We are seeing the question. Here x of n is given. We have to use DAF algorithm and we have to find 8-point DFT. Let's just write the given sequence. We find the individual samples x of 0, x of 1, like that. We will see the butterfly operation. For DAF algorithm, here A and B are the inputs and WNK is the twiddle factor. A plus B is the output. Similarly, A minus B WNK is also the output in the lower loop. Find the number of stages. Here totally there are 8 samples given. So capital N, number of input samples are 8. And then we have to find the stages M. The formula is log 2n. Here in the place of capital N, we have to substitute 8. Then that 8, we have to write like 2 power 3 because the base is 2. Then we can use the formula log a power b and base is a. So the answer is b. Similarly, here the answer is 3. Because the power of 2 should come. Power of 2 is 3. The next step is we have to find the twiddle factor exponent for each stage. Twiddle factor W and K that we know, and the exponent is small k. For first stage, 4 numbers of exponents will be used, 0, 1, 2, 3, 4 values. Similarly, for the second stage, 2 values of exponent will come, 0 and 2. For the third stage, only one value will come, that is k is equal to 0. Step is we have to find the values of twiddle factor. Twiddle factor formula we know, that is W and K. Wn is e power minus j2 pi by capital N. We are having 8-point samples, so n is equal to 8, we are substituting. And then the simplified form is e power minus j pi by 4. First, for k is equal to 0, we are calculating the twiddle factor, that is W8 0. In the place of k, we have to substitute 0. So e power 0 is coming, the answer is 1. Then for k is equal to 1, that is W8 1. The obtained equation is like e power minus j theta. E power minus j pi by 4 we got. So we can use the basic formula e power minus j theta. That is cos theta minus j sin theta. Here theta is equal to pi by 4. So our answer is cos pi by 4 minus j sin pi by 4. Similarly, we can find W82, that is for k is equal to 2. And then for k is equal to 3, W83 we can find. Now, first stage. In the first stage, one 8-point butterfly is used for DAF. First, we are writing the inputs x of 0 to x of 7. Now we are going to find the outputs for first stage. Here we are going to use the formula a plus b. Before finding a plus b, first we should know what is a and b for a particular output. For the first, we should find what is the input for that first output. For that, you can refer the green color arrows. For the first output, that arrow indicates that how we should proceed. Then that arrow, right side we are seeing on arrow, that arrow indicates that from the output, we are drawing an arrow that indicates a dot, red color dot. From that red color dot, there two lines are joining. So I have indicated by using the green color arrows that indicates that x of 0 and x of 4 is the input for first output. Similarly, we have to find the inputs for the second, third and fourth output. Then we have to use the formula a plus b. Now we are going to find the inputs for last four outputs. Here we can have a comparison of inputs. That is, we know the inputs of first four output. Now, if you see the fifth output, the inputs are 1 and 4. For the first also, the input is 1 and 4. The blue color arrow relates the first output and fifth output because these two have the common inputs. Similarly, now if we see the yellow color arrow, it relates second and sixth output. Second and sixth output has the inputs 2 and 3. Now you see the red color arrow. It relates third and output. So these two have the common inputs 2 and 3. Similarly, to 1, eighth output and fourth output. Dark blue color that indicates that 1 and 4 are the inputs for fourth and eighth output. Now we have to calculate the last four outputs. For that the formula is a minus b w and k. Already we got the inputs. So a minus b we are using, w and k we have to substitute. W and k will come in the order W80 and W81 and so on. Here the calculations are given. We are seeing the second stage. In the second stage, the outputs from the first stage, we can use it as an input. Now, the two butterflies. This butterfly is a 4-point butterfly. Now, in the first butterfly, for the first two outputs, we have to use the formula a plus b. And for the last two outputs, we have to use the formula a minus b, w and k. In this way, we have to calculate the output for the second butterfly also. Going to see the third stage. Here, 2-point butterfly is used. There are 4 numbers in 2-point butterfly. The outputs from the second stage, we are using it as an input for the third stage. Here in the first butterfly, the first output, we are using a formula as a plus b. For the second output, the formula is a minus b, w and k. We are calculating the outputs. Now, finally, we have to use the bit reversal operation. In the bit reversal process, there are 8 index from 0 to 7 that we have to convert it into binary. After converting binary, we have to reverse the bits. After bit reversal, we have to calculate the decimal index. The decimal index is 042611537. Stage 3, we got the output, but the output is in the bit reversal form. So we are comparing this output with the bit reversal index. Our first output is x of 0, but the second output is x of 4. X of 4, that index is in the bit reversal. Similarly, the third output, if you see, that is x of 2. Now we got the individual outputs, but it is in the reversed order. So, but we have to write the DFT as like x of 0, x of 1, x of 2 in normal order. So we can substitute the individual values. Finally, we are getting the x of k. Thank you all.